Bismillahirrahmanirrahim. Started with the name of Almighty Allah, the most beneficent, most merciful. So, last lecture was on stereochemistry, and in continuation with that, I would like you to share with you what is stereochemistry. It is a branch of the chemistry that deals with the arrangement of atoms in three-dimensional space, and on that the properties are dependent. But that matter, in my last lecture, I did mention to you the stereoisomers. What kind of stereoisomers are there? Geometric isomers and optical isomers. The geometric isomers are further categorized into configurational and conformational analysis, and then the optical isomerism. And this optical isomerism is the important domain of the pharmacist, not particularly for the pharmacist. It could be very important for every student who is taking part in vital science studies such as MBBS, BDS, GBM, all other vital sciences such as homeopathy and allopathy sciences are also included in it. And DPT is also important in that respect. This is the way where all these allied sciences people are very necessarily be taking part in it. So now I would like to continue in that relation that is called as interconversion of cis-trans isomers. If this is cis and this is trans, now I am dealing with currently how does one can be interconverted into another, how cis form can be converted into the trans form, and how the trans form is converted into the cis form. So in that respect, I would like you to give the examples such as an important method of bringing about cis-trans interconversion is photochemical methods. That means light is the most important. Photochemical methods are the most important one, and I gave you the example of photochemical reactions is atropine. If a doctor who is ophthalmologist and using the atropine for dilating the eye, and he has placed the atropine in an area where sunlight is passing over it, it will be destroyed. Cis form will be converted into the trans form. And as I talk to you, one form is a good medicine and the other form, which is a trans, could be very good poison. A trans could be a very good drug and cis could be a very good poison. In other words, these things are going on. For that matter, photochemical reactions are of critical importance to control the interconversion of one isomer to another isomer. So could you be able to understand this thing? This is very, very important for you to understand. If here and you could be able to understand, then you can follow till death, because this is that chemistry which is the crucial and important aspect of the pharmacist. And pharmacist's domain is medicine. And without medicine, no allied science could be run. For that matter, the knowledge of stereochemistry, which is a very, very specific science in this global village, is important for us, particularly for those who are sharing their knowledge in all kind of vital sciences. Now, excitation of a molecule by absorption of energy creates some measures of single bond character in the double bond. This is the most important one, which actually is not your domain. This is the domain of a pure chemist, but you must understand how does it could be able to play the crucial role from transferring from one isomer to another isomer. Thus, radiation of trans still beam by ultraviolet light cause isomerization to the less stable cis isomers. Now the example is at 1. Now here is a pretty good example of still beam. This is double bond. Now you can see this is phenol C6H5, C6H5, hydrogen, hydrogen. Now you can see opposite side or attachment of a similar kind, opposite side of the attachment of a similar kind molecule. That is why it is called as trans. If this hydrogen would be here and this would be cis, and this C2H5 would have been there, it would be cis. But this is on the opposite side. That's why they are designated as trans-stilbene. Now, when the light passed upon it, and it will be immediately converted into cis-stilbene. Similarly, I gave you the example of atropine. When the surgeon used atropine and placed the atropine in sunlight, light will pass on it and the cis form will be converted into the trans form. And cis form is active and trans form is not active. For that matter, a pretty good medicine is converted into a poison which is not known to all people. For that matter, this is that area wherein the pharmacist has to intervene and let it to explain to the clinician in a way that this is most important science. Lacking of this, ophthalmologist says, look at it. I opened the atropine and used it once. Very good results were there. And after that, when I'm using, the result would keep on feeble. The reason behind is that has placed the atropine in the sunlight and the active form is converted into inactive form. With that matter, the knowledge of this stereochemistry is of crucial importance for pharmacists, for clinicians, for all allied health sciences people, such as I did mention to you, DPT, then dentistry and homeopathy and all other allopathic sciences are being governed by it. Even Ayurvedics is very important in this respect to understand. Without this, no allied science would be governed. Now, another procedure is to treat the alkene with an acid. This probably causes isomerization. For example, the solution of maleic acid in aqueous HCl is isomerized to fumaric acid on heating. A probable example is as under. Now you can understand, here is maleic acid, and if you go back, you are a first year student and I'm giving you the chance to know where from this originates. TCA cycle, you would be able to find malic acid, and malic acid is converted into fumaric acid. Now you can see this malic acid is a cis form, CH2, COOH on the same side, H and H on the same side. Now hydrogen is acting upon it, and if you could like to draw the structure of this area, only this area, it could be like this. Now you can see this pi electron will be moving here, and this is the hydrogen, and negative charge will be created here, and this hydrogen will be get attached to it. And you can here see that this hydrogen is here due to this pi shifting here, and it has created a negative charge, and this positive charge will attract it, and it will be created this area. And this area is more prone to rotate in this way, rotate in this way, rotate in this way. Could you be able to understand? I'm talking about this area, capable of free rotation. And by rotating it, it can be converted into the transform. Now, COOH is here, COOH is on the opposite side, and hydrogen is on the opposite side. Now this has been converted into fumaric acid. These are the way that how by catalytic reaction isomers are converted from one form to another form. Likewise, fumaric acid could be converted to maleic acid. Likewise, this can go back. It should be understood that photochemical, catalytic or other procedures used to bring about interconversion give an equilibrium mixture of the two forms, the proportion of the two isomers being largely determined by their relative thermodynamic stability. So this is the conversion of one form to another form with a specific equilibrium. Now, the actual task, which is the dilemma of the pharmacist, and the pharmacist must be in a way that he should be able to understand with every respect, that is called optical isomerism. Just now I gave you the example how light does play a crucial role in this aspect, and we should have to know how these isomers with the help of light could be converted from one form to another form. That particular science is designated as optical, as the name indicates, optical light isomerism. So my dear, son and daughters, you should have to understand this is critical aspect which I am sharing at the moment. And if you could be able to understand it, then it's very good for you to be a very good pharmacist till death. Now, Liebel and Van Hoff in 1874 advanced the theory of tetrahedral geometry of carbon. You are well aware of it. Naturally, if the four atoms or groups attached to a carbon atom are different, the molecule can be described by two different geometrical arrangements as shown below. Now you can see here, this is the central carbon atom. To this one, this legend designated as A, one this designation legend designated as B, this designated as D, and this is designated as E. All these four are the different legends which have been attached to the central carbon atom. So this carbon is called as asymmetric or chiral carbon, which gives the pretty good role in stereochemistry of optical isomerism. Now, what you did, you placed a mirror here and you could get the mirror image of it. And that can be presented in this way. If this is the compound and mirror image would be like this. So this is important to understand here. This is one drop, this is another drop. So this is one form and this is another form. So I let you know they are called enantiomers to each other. And if you place a mirror image, and you could be able to see that this is a very good drug and this is very good drug. Why is it? Looking into it, these cannot be understood by students who are not sharing the knowledge of this respect. And the pharmacist has got the domain wherein he should have and she should learn all these things. Now this could be designated as object, and this is mirror, and mirror image is there. So object to its mirror image. Now they are called as enantiomers, and one enantiomer, another enantiomer. This enantiomer is like this, and this enantiomer is like this. Now you can understand, one say cis, another say trans, could be able to give you the idea of stereochemistry. So now this one could be a good drug, and this could be a good poison, or this can be a good drug, and this can be a very good poison. So these are the way we could be able to understand the stereochemistry. So now, naturally, if the four atoms or groups attached to the carbon atom are different, the molecule can be described by two different geometrical arrangements as shown. Molecules of the type C, A, B, E just now we described, where A, B, D and E are different atoms or groups are said to be asymmetric. The word has been used, A means none. Symmetric means symmetry, no symmetry. Such molecules can be represented by two spatial arrangements as shown above. I did already explain to you. Such that one is the mirror image of the other, but cannot be superimposed on one another. But cannot superimposed on one another molecule related to one another as object is to its mirror image are called enantiomers. Muy transparency. Such that one is the mirror image of the other. This is object and this is mirror image, or this is object and this is mirror image. So now you can see object to mirror image, but cannot be superposed on one another. If you place this upon it, could it be exactly fit upon it? E would be here, D would be here, whereas these are on this side. So this is non-superimposable. Non-superimposable. If you look at, this is this one, and this is in this way. And if you place it upon it, this is here and this is here. They are non-superimposable. One enantiomer, this is another enantiomer. Once one or more of the group attached to the central carbon are the same, the mirror image are superimposable and both arrangement corresponds to the same compound. Such compound would be asymmetric. Now here is that one. Once one or more of the groups attached to the central carbon are the same. Now look at, if this is object, this is mirror image. Now you bring this mirror image, can it be superposed upon it? As I am going to do it, look at, if this is one and this is mirror image and you are placing it in this way, now you can see these are being superimposed. But once when this is this one, this is this one, and when you place it in this way, it is non-superimposable. Non-superimposable. This is one enantiomer and this is another enantiomer. So this is a very good drug. This could be a very good poison, or this could be a very good poison, or this could be a very good drug. This is the thing which I wanted you to make it clear. And if you could be understand it, thanks to Almighty Allah, God gave me this opportunity to let you to explain. If you cannot understand it, please do talk to me. Without this, you should not be a very good pharmacist. Or more of the groups attached to the central carbon once one or more of the groups attached to the central carbon are the same. So this is central carbon. Say there is OH group, there is OH group, there is OH group, there is OH group. All are the same. Are the same. The mirror image are superimposable. If they are same, now you can place this upon it exactly as this is this, and this can be, if like this: alcohol, 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 alcohol. Now mirror image is like this, so you can superimpose upon it, exactly superimpose. So such compound would not be asymmetric. They are asymmetric compounds. They can give you such sort of thing which could be in here. So in this lecture, I did explain to you how can you convert one isomer into another isomer, and that is by photochemical reactions, by catalytic hydrogenations are being converted into it. And then I did talk to you optical isomerism, and as the name indicates, optic means light. How does light play a crucial role in this respect, and how does central carbon is act as a chiral carbon and a non-chiral carbon, and how many kinds of enantiomers are formed through it, that we have discussed just now. If you are unable to understand anything, I am available on mobile number 030041630075. Any moment you can respond to me and call me from say early in morning till late 11 p.m. at night. Thank you very much.